Alright, inverse trig functions. What are they? What do you do with them? Well, let's take a look. We're going to look at inverse sine, and we use that raised to the negative 1 power notation. Inverse cosine, and inverse tangent. Well, what does an inverse do? It gives you the value of a function after you undo it. An inverse undoes a function. Now, if we think about a trig function, just one. Here's theta, here's A, here's B, and I'll make the hypotenuse C. And if we think about the sine of angle theta equals opposite over hypotenuse, that's A over C, well, that would mean that the inverse sine of A over C would equal angle theta. That's what inverse trig functions do, is they give you angles. A trig function gives you the ratio of the sides of a right triangle. An inverse trig function gives you the angle involved in the right triangle. Now, let's take a look at the inverse sine first. And there are some restrictions on the domain. Just like the range for the sine, well, x is going to have to be between negative 1 and 1, and y is going to fall in the first or the fourth quadrant. Y has got to be between negative pi over 2 and pi over 2. Okay? So, if I looked at something like x equals square root of 3 over 2, I would have the inverse sine of the square root of 3 over 2, and then I would have to remember, or if I didn't know my unit circle, which by fact I do know my unit circle, unlike some of you, I know that the angle that would give me a sine value of the square root of 3 over 2 is pi over 3. Okay. Now, similarly, if I had the inverse sine of negative 1/2, and I said that equaled angle y, or equaled y, or I could even say angle theta if you wished. Well, I would have to think what angle, if I took the sine of it, would give me negative 1/2. Well, theta then would equal negative pi over 6. So what these inverse trig functions do is they give us a way of finding an angle. Now, if we look at the inverse cosine, y equals the inverse cosine. Again, x has got to be between 1 and negative 1, but this time y has to be greater than or equal to 0 and less than or equal to pi. So in other words, first or second quadrant with inverse cosine. Now, for example, if I asked myself what angle would give me a cosine value of the square root of 3 over 2, in other words, if I took the inverse cosine of the square root of 3 over 2, well, that would equal pi over 6 radians, or 30 degrees. Okay. Now, if we asked ourselves, if I had the inverse cosine of negative square root of 3 over 2, what angle would that give us? Well, that would give us 5 pi over 6 or 150 degrees. Okay, so there we go. Right? That's inverse cosine. Now, inverse tangent. Now, for the inverse tangent, again, we've got restrictions on x and y. Well, not really on x. X has got to be somewhere between infinity and negative infinity. So it's not like there's a whole lot of restrictions on x. It's just got to be a real number. But y has to be less than or equal to pi over 2 and greater than or equal to negative pi over 2. So again, this is first and fourth quadrant. If we asked what was the inverse tangent of 1, right? In other words, what angle, if we had an angle and we took the tangent of it, what would give us 1? Well, that would be pi over 4 radians. Okay. And similarly, if we looked at what was the tangent, what was the inverse tangent of negative 1? Well, that equals negative pi over 4. Okay. So, right, remember that this little sign up here means inverse. We have an inverse trig function. Now, back in the day, this wasn't always necessarily the desired notation. They would put ARC in front of them, like they would have an arctangent, or an arcsine, or an arc cosine. Okay, that was how they indicated an inverse trig function. Now, for some of these values, I'm going to expect that you can give the exact value, but not always. Because let's say that you had the inverse sine of 0.237. Okay? Now that doesn't necessarily come out to be any particular angle, but there just happens to be a little button on your calculator if you look at the second function for sine, and you go second, and then hit the sine button. You'll see sine raised to the negative 1 power. Enter 0.237 in there, hit enter, and you get 0.239 radians. Right? So it's quite honestly that simple to estimate the value of an inverse trig function. Right? We'll talk some more about this stuff on Monday, and you have a good rest of the weekend.